Hello my dear students, welcome to my channel NS educare. Today I am going to discuss some example of NCERT textbook and some other questions related to the first chapter. Okay, let us proceed. So take first question. So that every positive even integer is of the form so that every positive integer is of the form twice q and what we have, and that every positive odd integer, that every positive odd integer is of the form twice q plus 1, where q is some integer, where q is some integer. So this is textual question example 2. So solution: let A be any positive integer and B is equal to, then Q and R are two unique integers such that A is equal twice Q plus R, where zero less than equal R less than what? 2. So this is by Euclid's division lemma. Now what are the values of R? That is, R is equal 0 or 1. When R is equal 0, when R is equal 0, then A is equal twice Q. When R is equal 1, then A is equal twice Q plus 1. Now you see, this twice Q is even number because 2 is a factor. So what we write? Twice Q is an even integer, and we know, since twice q is an even integer, and we know every positive integer is either even or odd. Therefore, twice q plus 1 is an odd integer. Hence, every positive integer is of the form twice cube, and that every odd integer is of the form, what we get, twice cube plus 1. So question number 2, example 3 in text, so that any positive odd integer, so that any positive odd integer is of the form four q plus 1 or 4q plus 3. So let us solve this. Solution: let A be any positive integer and B is equal 4. Then by Euclid's division lemma or division algorithm, Q and R are two integers such that A is equal 4q plus R, where what we get, 0 less than equal R, that is remainder, and R less than 4. So that is, what are the values of R? R is equal 0, 1, 2 or 3. When R is equal 0, A is equal, how much we get from this? 4q. R is equal 1, A is equal, what we have, 4q plus 1. When R is equal 2, A is equal 4q plus 2. R is equal 3, A is equal 4q plus 3. Since 4q plus 2 are even and we know every positive integer is either even or odd. Therefore, 4q plus 1 and 4q plus 3 are odd. Hence, every positive integer is of the form 4 cube plus 1, or what we get 4 cube plus 3. Another question, so that every positive integer is of the form thrice q, or thrice q plus 1, or thrice q plus 2 for some integer q. So solution, let A be any positive, or fully you can write positive integer, and b is equal 3. Then by Euclid's division lemma or division algorithm, there exist two integers q and r such that A is equal thrice q plus r, where 0 less than equal r, r less than 3. That is, r is equal 0, 1 or 2 when r is equal 0, A is equal, what we get here, if we put r is equal 0, thrice q. When r is equal 1, A is equal thrice q plus 1. When r is equal 2, A is equal thrice q plus 2. So from these three, we see that thrice q plus 1 or thrice q plus 2. Therefore, every positive integer is of the form thrice q or thrice q plus 1 or thrice q plus 2. Question number 4. So that n square minus 1 is divisible by 8, if n is an odd positive integer. If n is an odd positive integer, odd positive integer. solution. What we do? How will you do? We know that. We know that any odd positive integer is of the form 4q plus 1 or 4q plus 3 for some integer q. So here we have two cases. So case 1, when n is equal 4q plus 1, then n square minus 1 is equal 4q plus 1 whole square minus 1 is equal 4q square, that is a plus b whole square, a square plus 2 into a into b plus b square form minus 1 is equal, this will be 16q square plus what is the 8q, and this 1 minus 1 it will be 0. So what we have, from these two we take 8 common, then here we have twice q square plus here have what, q is equal, you can write in this form also, where m is equal twice q square plus q for some integer m. Now 8m is divisible by 8. Case 2, when n is equal 4q plus 3, n square minus 1 is equal 4q plus 3 whole square minus 1 is equal 4q square plus 2 into 4q into 3 plus 3 square minus 1 is equal 16q square plus 4 to the 8 is the 24q plus this is 9 minus 1 is equal 16q square plus 24q plus 8. So from all the three terms we take 8 common. Here left twice q square plus here 3q plus 1. So this can be written in this form, again 8m, where m is equal twice q square plus thrice q plus 1 for some integer m. Now again 8m is divisible by 8. Therefore n square minus 1 is divisible by 8, where n is an odd positive integer. So let us take question number 5. Find the HCF of two numbers 963 and 657 and express it as a linear combination of them. So what we have, find the HCF of 963 and 657 and express it as a linear polynomial, of 963 and 657. So to do this, we apply Euclid's division algorithm. Solution: given integers are 963 and 657, where 963 greater than 657, by applying Euclid's division lemma or division algorithm, we get what 963 is equal 657. Now we divide this 963 657. This is one time first, so 7 5 6. We subtract this, 13 minus 7 6, 5 minus 5 0. Here left 9 minus 6 3. Again we divide this 657 by 306. So this will be again 2 times, 2 6 are 12, 0 0 1 6. 7 minus 2 5 and 5 minus 1 4. Then we divide this 306 by 45. How many times of this? Will it be 8 times? Not 8 times, 7 times. 7 5 is 30. No, the 35. And 7 for the 28 plus 3. It will be more than this. So it is not how many times? 7. So it will be 6. 6 times. 6 5 is 30, 0, carry 3. 6 for the 24, 3 27. Subtract, this is 6. And here left how much? 10 minus 7. 10 minus 7, 3. Again you divide this by 45 by what? 36. So one time is 36, then 9. So here I have shown this 9 is 36. So this 9 4 is 36. So remainder 0. So what are the steps? You see 657 into 1 plus this time remainder 306. Next 657, when we divide this by 306, how many times of this? We get this 2 times, and in this time remainder is 45. Now next, when we divide 306 by 45, the quotient is 6 and the remainder is, what is the remainder? 36. Now when we divide 45 by 36, we get this is 1 time and remainder 9, and last 36 is equal 9 into 4 plus remainder 0. Therefore HCF of what numbers? 963 and 657 is equal, this last non-zero remainder is 9 or last divisor is 9, so this is 9. Now we are to express in the form of linear polynomial. In the form of linear polynomial we express these two, or HCF. So what we have from this, HCF is 9. Now 9 is equal, from this step we see 9 is equal 45 minus 36 into 1 from this step. Now in the second step you see this, in 40, or this is 36, what we get? In place of 36 we can write 45 minus 300, 6 minus 45 into 6 is equal 45 minus 306 minus minus plus 45 into 6 is equal, we take this together, then we get 45 into 7 minus 306. Now you see the previous step again. 45, this 45 can be expressed as 657 minus 306. So we write like this. Now you see in this, in place of 45 here we can write 657 minus 306 into 2 whole into 7 minus 306. Now next step, you see this 657 into 7 minus 306 into 14 minus 306. Now next step, what we get? 963, not this 963, this will remains in 657 into 7 minus these two, if we take together we get 306 into 15. Now in place of this 306, what we get? Minus 657 into 15. So from this we get 657 into 7 minus 963 into 15 minus minus plus 657 into 15. Now we take these together. What we get? 657, this 7 plus 15. So we get 22 minus 963 into 15. Or you can write like this term you take as the first term, or 963 into minus 15 plus 657 into 22 is equal 963 into x plus 657 into y, where x is equal how much? Minus 15 and y is equal 22. So this is in the linear form of two variables x and y.